Hello students, in this video I will explain you galvanic cell. Galvanic cell is a type of electrochemical cell in which the spontaneous reactions take place. Okay, now when we are using zinc anode and copper cathode, it is a type of Daniell cell. Daniell cell is a type of galvanic cell. Okay, now zinc rod is dipped in zinc sulfate solution and copper rod is dipped in copper sulfate solution. The two half cell is connected by a salt bridge and the wire outside completes the outer circuit. You also know about the salt bridge and its function. You have studied this in your previous class. Here we have taken potassium sulfate solution jellified in agar-agar in the salt bridge. Let us see some important features of this galvanic cell. Now, zinc rod where oxidation takes place is anode, and copper electrode at which reduction takes place is cathode. It is negative and it is positive. Okay. Now the electrode is rich in electrons and pushes this electron to the outer circuit. So it is designated negative pole. On the other hand, copper electrode is in the need of electron and it pulls the electron from the outer circuit, and thus is a positive electrode, is a positive pole. Now electrons flows from negative pole to positive pole in the external circuit, whereas conventionally current flows from positive to negative pole. Oxidation reduces zinc metal to zinc ion. Similarly, here due to reduction of copper, it get deposited in copper rod and leaves behind sulfate ion in the solution. Okay. To maintain the electrical neutrality of the two beakers, cations and ion moves through the salt bridge as shown. That is, zinc ion move from here to this beaker and sulfate ion move towards this beaker. The copper sulfate solution is deposited as copper from the copper sulfate solution is deposited on the copper electrode and sulfate ion migrate to other side. Concentration of copper sulfate in this half cell decreases. With the passage of time, the flow of current also falls. That is, current falls. The weight of copper rod will increase while weight of zinc rod will decrease as the cell works. If we apply an external electrode potential, external EMF. Suppose we are applying an external EMF to the cell, the reaction takes place as long as this external EMF is less than the cell EMF. When external EMF is less than cell EMF, electron flows from zinc to copper rod and zinc dissolves and copper deposits. When the external EMF becomes equal to the cell EMF, no current will flow and the chemical reaction within the cell will stop. When the external EMF becomes greater than cell EMF, the current flows from copper to zinc, that is in the opposite direction, and in that case zinc will get deposited and copper will dissolve. That means it will start acting as an electrolytic cell. Okay. Now the overall reaction is written like this, and the representation of the galvanic cell is the oxidation half cell, then divided by a salt bridge, then you will write metal ion and metal. That is the reduction half cell. For this Daniell cell, we can write zinc to Zn2+, then concentration of the ion in the solution, then divided by a salt bridge, then copper ion in the solution and copper metal. Now let's understand the next topic, electrode potential. To understand this, consider a metal rod dipped in the salt solution of its own ion. Okay, there may be three possibilities. There may be collision of the ion with this metal rod and no change. In that case, no possible reaction or change is visible. The second possibility is that metal ion in the solution collides with the metal rod, gains electron and gets changed into metal atom. That means reduction of these ions occur. That means reduction takes place. The third possibility is that the metal from the rod dissolves in its solution. That means it loses electron and goes to solution. That means oxidation is taking place. The oxidation or reduction takes place on the basis of the tendency of this metal ion, whether it has tendency to accept electron or whether it has tendency to lose electron. Right. Now, when these two are happening, that is electron are lost or gained, a potential difference is set up or potential difference exists. This potential difference or electrical potential difference between the metal and its ion is known as electrode potential. The electrode potential can also be defined as the tendency of the metal electrode to lose or gain electron when it is in contact with its own solution. Right. Now, if we are taking the concentration of solution as 1 molar and temperature is set at 298 Kelvin, the electrode potential is known as standard electrode potential and written as E0. If we are using a gas like gas electrode like hydrogen gas, then pressure is taken at 1 atmosphere and temperature equal to 298 Kelvin, and this will give our standard electrode potential. Now measurement, how an electrode potential is measured. The absolute value of this electrode potential of a single electrode cannot be determined because oxidation half cell and reduction half cell cannot takes place alone. The oxidation half cell and reduction half cell can't be set up alone. Okay, it can only be measured by using a reference electrode. Reference electrode like standard hydrogen electrode or normal hydrogen electrode. Because we have taken hydrogen electrode because the reduction electrode potential of hydrogen is taken as 0. E0 for this cell is taken as 0. Now this setup shows the standard hydrogen electrode, where a glass vessel is taken, a platinum wire is suspended which is coated by a platinum black. Here the H2 gas is passed, which is as 1 bar, to the electrode, over the electrode, and there is an outlet for the excess gas. Okay, when this type of electrode is connected to another half cell or electrode, for which we have to calculate the EMF, this electrode will either act as reduction half cell or oxidation half cell. For example, if we take zinc dipped in zinc sulfate solution and connect it with a standard hydrogen electrode, it will start acting as anode. If we take copper dipped in copper sulfate solution and connect it with hydrogen electrode, it will start acting as cathode, because copper with respect to hydrogen has a tendency to accept electron and get reduced, whereas zinc with respect to hydrogen has a tendency to lose electron and thus get oxidized. Okay. Now, since the EMF of the electrode potential of hydrogen electrode is taken as 0, by calculating the E naught cell, we can get the electrode potential of this electrode, because whether it is E naught electrode minus this hydrogen electrode will be taken as 0. Okay. Now it is important to note that all the electrode potentials are expressed in reduction potential. Okay. So if we want to get the reduction potential, we have to just put a negative sign before oxidation potential. Okay. Now if oxidation is taking place, this setup will give the oxidation potential of this electrode, and if reduction is taking place, this electrode is giving reduction potential of this electrode. To get reduction potential, we will put negative sign before oxidation potential. Now the difference between the electrode potential of two half cell, that is E cathode minus E anode, it gives the cell potential or cell voltage, the cell potential of or cell voltage at any condition. But when no current is drawn from the cell, the EMF is known as the cell potential is known as EMF. That is, the EMF is the cell potential when no current is drawn or the circuit is open. Next is electrochemical series. When all the reduction potentials of the metals and species are arranged in an order, it forms a series known as electrochemical series. You have studied the electrochemical series also in your previous class. Let us see what are the application of this series. We can compare the relative oxidizing and reducing powers of the metal. More negative is the reduction potential value, more easily it is reduced, and it will be a more easily can be oxidized, and it will be a good reducing agent. Okay, so metals are having negative value and are acting as a good reducing agent. We can also compare the relative activities of the metals. Comparing activities of metal like magnesium, zinc, iron, copper, silver. For example, if we take magnesium, zinc, the activity of these two metals, magnesium is more active than zinc. That means this metal can displace this metal from its salt solution. Okay. We can also calculate standard EMF of the cell by using this relation, E naught cell is equal to E naught cathode minus E naught anode. We can also predict whether hydrogen gas is liberated from the acid by the metal or not. And also prediction of the spontaneity of the reaction. If E naught cell of the reaction is positive, if E naught cell comes out to be positive, the reaction will be spontaneous, and if it is negative, the reaction will be non-spontaneous in that condition. If we reverse the electrode, that is, if we make the anode, if we reverse the electrode, that is, we make anode as cathode and cathode as anode, thus just reverse it, then somehow the reaction may become spontaneous, and then it will come out positive. Okay, that's all for today. Thank you.